If you are lost on how to, this is expand here. If you're lost on how to do that, I'm about to go over it on the board right now, okay? This is a part of your test. You're going to take a CFU over this. This is 11.3, okay? So with expanding, I choose on problem number 1 because you've got this whole thing right here raised to the third power. I think it's easier to take care of the exponent rules first. So like for instance, because x, y, and z is all cubed, this is the same thing as log x to the third, y to the third, z to the third. Do we all agree with that? Yeah. Okay? I think that's easier just to take care of that power. Then I'm going to separate everything out based on the fact that x, y, and z are all being multiplied. So log properties say if your argument is being multiplied, then you're going to separate those into separate logs that are doing what? Adding log x cubed plus log, notice I'm not writing on my answer blank yet. Log y cubed plus log z cubed, right? Am I done? No. Why am I not done? Because I cannot have an argument that has a product, a quotient, or an exponent. So where do your exponents go? In the front. So my final answer, and it just goes right in front of that log. So my final answer will be 3 log x plus 3 times log y plus 3 log z. You can put parentheses around those arguments. You cannot. What I will be looking for is 3 being in front of each of them, and then all 3 of them being added. Yes?
I got that, but since there was no log, I just put log base.
Okay, so let's talk about the base. There's not a base written down. What is that implied to be? 10. Do I need you to write that in? I don't need you to do that. That's more for like when we convert or find inverses, when you actually need to change form, you need to know what the base is. As far as expanding and condensing, the base like truly doesn't matter because it will it will be the same no matter what. Okay, so that's how you expand the first one. I would make sure I know how to do. Honestly, all these are important. They're all star worthy, but there we go. Okay, so that's the first one. All right, let's look at the second one. I'm gonna have to erase some of this so I have more room. Here's the second one. There's a little more going on the second. But following the same idea that I just said with kind of cleaning up my exponent rules first. So this numerator is the 5th root of 3y. The first thing that I would do is write that as log. Again, base 2 doesn't really matter. Okay, that's neither here nor there. Because the 3y is all in that 5th root, right? That means the 3y is all raised to what power? You need to know that, okay? Both the 3 and the y to the 1/5 power. The denominator, what's the only thing that's raised to the 2nd power in the denominator? Just the x. The 7 is not. Now, we have to separate out the 7. We have to separate out the x. We have to separate out the 3 and the y. But before I do that, what do I need to do with that 1/5 power?
Put it behind it.
Well, I am going to opt to bring it in because it's applying to the y and it's applying to the 3. Okay? Because the whole 3y was in the radical. Does that make sense? So really what I'm expanding, and again, I'm going to kind of write under because I have a lot of work here. This is log base 2. My numerator is 3 to the 1/5 power. I don't know what that is, so just leave it. That's fine. Y to the 1/5 power. My denominator is 7x squared. Yes?
I put the 1/5 before it.
You will put the 1/5, but it has to be in front of the log base.
Yeah, it's right before log. Like, does it
Both of them?
All of them.
Only the top. Only the first 2. Yeah. That's okay. Okay, so now I can separate this out. How many times am I going to write log base 2?
Twice, or 4 times.
4 times. Why is it 4?
Because it's all.
Because there's a, name them. There's an argument of 3. There's an argument of y There's an argument of 7, and there's an argument of x, okay? Are y'all okay if I bring the exponents in front in one step? Okay, so we'll have 1/5 log base 2 of 3. What's next? Plus another 1/5 log 2 of y. Y minus.
Because it's division.
Log base 2 of
7.
7 minus what? 2 log base 2 of
Oh, that's what I put.
x.
I didn't do the formula.
That's okay. Okay, does that make sense? So numerators need to be positive, denominators need to be negative. Do y'all know why they're negative? Because it's a quotient. Also, you can think of it as like that's giving exponent 7 an exponent that's negative, and negative exponents, that's why the bases go in the denominator. So that's why those are negatives there. Okay, I think we could probably do this one in our head pretty quick. Natural log 7x to the 3rd, y to the 9th. All right, let's go ahead and do the final answer. There's no kind of funky exponent rules that we need to do. So, what is it?
Log base e.
Log base e, but you keep that as natural log. So natural log 7.
But it's more expanded.
I want you to keep natural log. Plus 3 times natural log of plus 9 natural log of y. Okay? So those are, come on, catch up. Isn't that catching up? There we go. Okay. Any questions on that one? That one's pretty easy, right? Okay, what about this one right here? Is the 3 in the square root?
It is in it.
Is the 3 in the square root on number 4?
No, it is not.
No. So this is log base 6 of 3. This is x to the 5th, y to the 4th to what power? 1/2. 1/2. So then, what should you do with your outside exponent?
Oh, you gotta put it inside. That's what you would say.
Where did we get the 1/2 power?
From the square root. Oh, I thought it was keep copying.
No. Okay, hey, that's the question. If y'all are confused, like that's a big 3. That is a 3 times something, okay? Versus number 2, do y'all see how that 5's a little bit smaller? If y'all are confused on the test, please ask. I don't want you to just like guess and get something wrong, because I understand your thinking. That 3 is too big to be a cubed root. So it's 3 times x to the 5th, y to the 4th, all that to the 1/2 power. Now, you need to know that this 1/2 power has to multiply in. So this is going to become 3 times x to the 5/2, right? Because 5 times 1/2 is 5/2. What's 4 times 1/2?
2. Keep copying.
So that's that's kind of when you clean up that radical, what it looks like. I would clean up the radicals. I would take care of outside powers going inside like I did all of that very first thing before I start expanding. Okay? Now I'm going to separate it out. How many times am I going to write log base 6?
For
Log base 6 of
x over, or 5 over x 5.
3. I'm going to do the 3 first.
Okay, 3.
Plus,
Wait, are we not writing it fully?
I'm writing my final answer. 5/2 log base 6 of plus,
You just put 3 first. Okay.
I would go in order. I would go in order left to right as far as how I separate those.
Yeah.
Okay, this is expanding. Any questions before I move on? Any questions about expanding? I don't know. Typically, people say condensing is easier, but everyone's different. So again, you're doing everything backwards, meaning the last thing I normally do when I expand is pull the exponents in front. The first thing I do when I condense is pull the exponents back. If there's any distributing to be done, number 6, number 7, I would do that. 4 and 5, we don't have any of that, so we'll just jump right in it. And again, this is the bases of the logs. Don't really matter, and expanding and condensing. So just go with it, okay? So the first thing, there's nothing in front of natural log 7, so I don't have to do anything with that. But what do I need to do with this 2 right here? Pull it back, so this will be natural log of 7 plus natural log x squared. And you don't necessarily have to do this in as many steps as I am. I'm just trying to give you one good explanation. Pull back here. This will be... what is that? Natural log x to the 1/2. Okay? You could, okay, here's my thing with the roots. Yes, 1/2 power is a square root. I would rather you keep it as a fractional exponent. Okay? And here's why. When you put this together, exactly. You're going to have natural log. You only have to write that one time. What are you doing with all those arguments? 7, x squared, and x to the 1/2. They're all multiplying. 7 times x squared times x to the 1/2. Now, are you fully condensed? Because how many base x's do you have? 2. We don't want that. Okay, so we need to follow our exponent rules that say when 2 bases that are the same are being multiplied, which is what's going on, what do you do with those powers? What is x squared times x to the 1/2? You don't multiply the powers. What do you do with the powers? Combine them how? You add 2 plus 1/2 with the exponents. So this is 2 with a denominator of 2 is 4 over 2. 4 plus 1 is, so this becomes x to the 5/2. So if you, I know I said this in the video, you're condensing, hey, stop. You're condensing and you're simplifying. So your final most condensed version would be natural log of 7 x to the 5 over 2. So you might have to do that. You might have to apply some of those exponent rules. And if I say might, I mean will. You will have to apply some exponent rules. Side by side exponents, add. 1 over the other, dividing, subtract. Exponent to exponent multiplies. You need to practice that. Okay? Log 7. Log of 7x to the 5 over 2. Okay? I'm going to kind of write number 5 over here because I'm all over the paper. This is why I never really write on the screen because I'm too messy. Okay, pull your exponent back here. Pull it back, pull it back, pull it back. Okay, I think I can do this in one step. How many times am I going to write log base 7? Well, in my final answer, I'm only going to write it once. Okay? I would, if you see a minus sign and you're condensing, I would go ahead and open up a fraction bar. Yes?
On number 7, is that a 3 on the numerator?
I don't know. I'll have to zoom in. Yes, it is. Okay? All right. So my first argument is going to be x squared, because when I pull that back, it's going to become x squared. Is x squared going to go in the top or the bottom? Top. X squared. My next argument is minus y to the third. Where's y to the third going to go? In the bottom. And then what about z to the 2/5? Why is that going to go in the top? Because it's being added. There's your answer. Okay, the only other... Exactly, because what's happening is basically like, okay, think about this. That -3 in front of the y, if you pulled the negative back with it, it would be like y to the -3rd power. And in exponent land, that means your base, y, has to go in the denominator. Okay? All right, on number 6, what I would do here is distribute. So this is log 5 plus log x. Nothing going on with that. You are distributing a -3, so it's -3 log x. -3 times 1/3 is negative what? -1 log y, or just negative log y. So I would distribute here and here. And then I'd pull everything back and simplify. So I'm writing log 1 time, opening up a fraction bar. What's going to be my numerator? 5. What else? X. What's going to be my denominator? X to the 3rd. Why? Is that fully simplified?
No.
What can you do with this? This is another exponent rule you need to know.
5x squared.
So it becomes log. So the x squared goes on the bottom because the bottom's bigger. So x squared y, and then 5 goes in the top. That's your fully condensed. Do we need to do the last one?
Yeah.
The other one had parentheses. You do the same thing.
No. This one's harder. You know what? Yeah, you're right. We'll do it on CFU.
I think you will do on the CFU, honestly. I think you will. Okay, so I'm going to pass out the CFU. I think it's like 6 questions. If you're not done with 11.3, 11.4, work on that. CFU first, then work on the homework. If you're finished, we're going to grade the CFU, so don't turn them in. Just hold on to them. But if you finish, you can go ahead and pick up a test review. What we're going to do now, I'm going to come around. I'm going to check that you finished the homework, okay, the practice. I have an answer key to the practice right here, okay? This will be posted on Canvas tomorrow, all right? But I've got it here. CFUs, you should have 2. I passed back your one from last week. The one that you just graded, you can keep once I get the grade. I will post the answer keys to the CFUs on Canvas tomorrow. They are good problems. What you're going to work on while I am collecting CFU grades and checking homework is the test review. It's a lot of pages. It's not a whole lot of problems. The transformations problems take up 1 per page. We gave you 5 transformations, okay? You have, okay, stop talking. You have 5 transformations practice problems. Your test has 3 at the most, if not 2. But it is an entire test topic. We have not talked transformations since March 18th and 19th. It's April 2nd. So that's why we put 5 on there, because this is the oldest thing. In my opinion, it's the one I'm most worried about. If you know how to do this review, then you should be totally prepared for the test. Watch the B values. You've got to know the points. You've got to know those parent function points. Have your notes. Have your CFU. Let me know if you need help on that. The second topic of the review, so again, let me go to the review. The second topic is, so here's a bunch of transformations. The second topic is just rewriting. Go to page 6, you're going to like this. Rewriting, this is all or none, no partial credit on that. If you can't rewrite or convert, I think is the other way we said it, you're not going to pass this portion of the test. Okay, it's very easy. You do not know how to do evaluating. So 7 through 10, you may be able to figure out. I think I worked them out on the answer key if you're curious. That will not be tested on this test, so don't stress about it. Okay? Converting and finding inverses is on topic 2, so page 6 and 7. Expanding and condensing is page 8. That is the third topic. This is 3 separate grades. Okay? So again, it's a lot of pages. It's just really those transformations that take forever. I have a review key. It's up here. Will be on Canvas tomorrow. Okay? So just give me a minute because I have to get through 8A. But I've got everything up here today. I'm going to come check homework today. Record CFU grades. We're working. This is what I wrote at the top of my page for transformations. If you would like to write that down, those are your transformation points. B to the x, and then log base b to the x. You are not going to be given those points on the test. You need to know which function has which type of asymptote and where it is. You need to know to factor out b values. All the things. Okay? All right, we're working for the rest of class. Have your CFU and your homework out while I come around to you.